Okay, problem number 6. A fish jumps out of the water at a vertical velocity of 1.2 meters per second. How much time is the fish in the air before it strikes the water again? They didn't give us too much information, but they want to know how long will that fish be in the air. Alright, so to start off the problem, we'll have some more room this time. Hopefully it'll be nicer. We have to write down what do we know in this problem. So to start off, they gave us this 1.2. That was the speed or velocity that the fish left the water. So at the very beginning of its motion, the velocity initial, that's what we're going to label it, is equal to that 1.2 meters per second. Okay, now what else do we know? Well, we know this is on Earth, because it's a fish, so while it's in the air, gravity is going to accelerate it at negative 9.8 meters per second squared. Okay, in addition to that, we know it's going up and it's coming back down. When it leaves the water, it's going at a speed of 1.2. As it goes up, it's slowing down to the top, it has a speed of 0. When it gets back down to the bottom, it has that same speed, but the negative direction. So the velocity final for this scenario, when it goes up and it comes back down, it's going to be that same amount, 1.2. However, it's going downward, so we have to add a negative to that. Its final velocity will be the opposite of its initial. Okay, using this information, I think we have enough to find out the time. We are trying to solve for delta t. That's what it's asking for. Okay, in order to do that, we have to pick the right equation. If we look at the information that we've wrote down, we haven't said anything about how high this fish got. They didn't ask for it, and it wasn't listed to us. So knowing that, and looking at our motion equations, we should see which one to pick. Equation number 1 has nothing to do with delta y. It has nothing to do with height, just like our problem. So we're going to use equation number 1 for this problem. So over to the side here, we're going to write down equation number 1, which is velocity final is equal to velocity initial plus acceleration multiplied by time. We're trying to solve this equation for delta t. So we're trying to get this by itself. Once again, I'm going to plug in the numbers first, and then we'll solve later. So velocity final, we know, is the negative 1.22. Sorry, just 1.2. It's a different problem. Velocity initial is the positive 1.2. Plus, our acceleration is negative 9.8. All these signs are really important, guys. Make sure you have those positive and negative signs where they should be. Multiplied by time, remember that's what we're trying to find out. Okay, first step is we have to get rid of that 1.2. So right now this is added to the right side of our equation, so to get rid of the 1.2, we have to subtract it from both sides. We're subtracting 1.2 from each side. What will happen is our 1.2's go away over here, and we're left with negative 1.2 minus 1.2, so we're really just doubling that side. So 1.2 minus 1.2 will give us a negative 2.4 on the left side of our equation. It's equal to what's left, which is negative 9.8 times delta t. The last step is we have to get rid of that negative 9.8. So to do that, this is 9.8 times delta t. The opposite of that is dividing. So we're dividing each side by negative 9.8 divided by negative 9.8. So once again, on the right side of our equation, those numbers just go away. What we're left with is 2.4 divided by negative 9.8. Let's put that in the calculator. 2.4 divided by 9.8 gives you an answer of 0.245 about. Okay, that's what delta t is equal to, because all that's left on that right side of the equation is delta t. Now we measure time in seconds, so don't forget to put a label on that. Notice in the calculator, once again, I did not put the negative signs because I saw that it was negative divided by negative. I knew my answer had to be positive. If you want to put the negative in the calculator as you type it in, that's also fine. There's your answer for problem 6.